So all of these brackets mean like resonance structures. Usually they're probably horizontal, but anyway. These arrows also mean resonance structures.
And so if the original carbocation was a primary one, would it still like flip and everything?
Yes. Yeah. It would. If we had just drawn it like this.
Yeah, that wouldn't like change anything at all. I guess then wouldn't the first and the third be the exact same thing? So there would only be two resonance structures?
It would be... No, I mean they're still different because it's you're right, like if you flip this compound around and you were naming it, it would be the same structure. But if all these carbons stayed in the same place and all you moved were the pi bonds, this is showing, hey, this pi bond moved this time and it's on this carbon and on this carbon and on that carbon. Does that make sense?
Mm-hmm.
So you're right. And that's a good point to bring up. I drew it secondary because up to this point you've never formed a primary carbocation.
Oh, that's true.
But you're going to see a reaction and you're going to be like, well, that's not going to happen. It'll make a primary carbocation.
Mm-hmm.
If it's next to a pi bond though, or a system of pi bonds, a conjugated system, all of a sudden you can make a primary carbocation because it's not really primary. It has resonance delocalization. And the more resonance structures it has, the more spread out that positive charge is. There's a little bit here, a little bit here, and a little bit there.
Because I guess it isn't the three separate structures.
It's all, yeah. Yeah, it's not this for a second, then it flips to this, and then it flips to that. It's all of these simultaneously, but we can't draw it that way, so we show has these types of characters. Yeah.
Okay.
Yeah, so now that's another thing to be aware of. Like, okay, could I make a primary carbocation? Because it's not primary, it's allylic. It's next to a pi bond.
Gotcha.
So, good. That was a nice catch. Okay, so that was what type of system?
Conjugated.
A conjugate. This is a conjugated diene. Good. So we've covered conjugated and isolated. And what's the last one?
Cumulated.
Cumulated. And do you remember? Or can you give me an example?
Let's see. Those in which one carbon atom is common to two carbon-carbon double bonds. So I say, like that.
Yeah.
So a carbon in between two double bonds.
Good. Yeah. So instead of the conjugated, the two enes, the two pi bonds were separated by one single bond. Isolated, they were separated by more than one single bond. Cumulative, they're right on top of each other. They're back-to-back pi bonds. Do you think this would be more or less stable than...
I feel like it'd be less, because it's not going to be able to switch anywhere. Or maybe, can the double bonds like flip positions? Or can it even swap anything?
You know, I don't know too much about these. I mean, I'm sure they can do some things, but I just remember learning when double bonds are back-to-back like this, it's the least stable type of diene.
Okay.
It's just not favorable. So if we were going to rank them, we would say that cumulated is least stable. Least stable. Which one do you think is the most stable?
The conjugated.
Conjugated, good. So most. And then isolated is in the middle.
Okay.